Okay, let's continue. Great. We have equals negative 1/4 x e to the negative 4x. That's positive. Minus 1/16 e to the negative 4x plus constant. Okay. It looks like I can factor out a negative 16. And e to the negative 4x. That's going to give me 4x plus 1. Naturally, that negative 4x, we want that on the denominator. So negative 4x plus 1 over 16 e to the 4x plus constant. Yeah, there should be a constant. There should be a constant. Go ahead and write one in. Okay.
Excellent.
Number 9. 9. Excuse me. Integral. Natural log of x plus 1 dx. Oh. No. You could, but then you have the antiderivative of natural log of u. That's kind of sideways, isn't it?
Integral by parts.
Integral by parts.
Yes.
Right, so hang on. There is a U-substitution that you could make. However, in order for you to make that U-substitution, you need to right now be able to tell me the antiderivative of natural log of u. Can't do it. Do you have it memorized? No. There we go. Okay, so we're going to use integral by parts. Let's go down for our candidates for u. Do we have a natural log function?
Yes.
Okay, my u is the natural log function. Everything else is going to be my dv.
Oh, interesting. Okay. I'm okay with this.
Okay, du equals dv is equal to x, or v is equal to x. Okay. Equals
Yes.
x. Actually, I should not do that. The double equal means something.
Really? It just super equals that.
But if we don't know
Okay. Let's take a look at what we have. Taking a look at this now. I can't separate a denominator. That is against the laws of algebra. Okay. So, U-substitution. Now my u is going to be equal to x plus 1. And du is going to be equal to dx. Great. Let's rewrite that now. That's going to be equal to x, natural log of x plus 1 minus antiderivative of x over u dx. We got problems? Oh yeah, this is a du, you're right. We got problems?
Yes.
Yeah, there's an X and
There's an X and a U.
Good. What we can do here is we could take this right here and transform that. By the way, x is also equal to u minus 1. This is an instance of that substitution after a U-substitution.
Oh. Oh yeah. I forgot you could do that. That makes sense. Okay.
Okay. X natural log of x plus 1 minus the antiderivative of 1 minus 1 over u du. You can separate a numerator, you just can't separate a denominator. Hey, what's the antiderivative of 1?
U.
What's the antiderivative of 1 over u?
Natural log.
Wait, what? I'm sorry, where did I lose you? Here?
Down,
Here.
down,
Here.
there into the next one. Yeah.
Yeah, this is u over u minus 1 over u.
Yeah,
Yeah.
that makes sense. Okay, like the next. Oh wait, now that makes sense. Then where would the other u? Yeah. Shouldn't that be 1?
Antiderivative of 1 is
Oh, antiderivative of 1. Keep going.
Oh, I see how you did that.
Because 1 over u is the
That's like
natural log of the absolute value.
equals x natural log of x plus 1 minus, hey, what's u?
X plus 1.
Plus natural log of
X plus 1.
x plus 1.
Should the first natural log be an absolute value? Because negative.
No,
Why not? Why is the second one?
because the second one comes from an antiderivative.
Okay. That one's separate.
Okay, almost finished, please. X natural log of x plus 1 minus x minus 1 plus the natural log of x plus 1 plus constant. But wait, that's constant, isn't it?
Oh god.
Oh, it's just part of the constant. What? We're just writing. Oh.
Yeah, that looks right.
I don't think it's the first time that I see that. Same with this. Yeah. That's literally what I do. I'm like, it could be this one. But it also could be this one. Then I think about this, and I'm like, this one's more like this one.
A lot of the times.
We lost it.
No, you distributed the negative, and then a negative one is like is a constant, so you don't need to write it. So like it's like the extra. And this is different. Because you had Well, yes.
It's
Number 12 is a little bit.
Is that it?
Yeah.
how'd you get there?
Because if you add two natural logs, you multiply what's inside.
No.
Something. Isn't that
We just
cool?
factored. They both have a natural log of x plus 1. So we gather.
I like it.
What'd you do?
I just factored.
Has a 1 in front of it, so it's like, okay.
I just factored.
What happened to the x for the L and x L?
That's that x. Distribute this. Distribute. This would be a lot better if this was organized. Guys, we have a long year ahead of us. Okay. We have a long, you will see problems that are much longer than this. Okay? This is not even a long problem. I hate to break it to you. You're going to need a lot of concentration. You're going to need a lot of focus. Okay. And okay, if we lose focus every time we encounter some difficulties, that'll just make it twice as hard for you. Okay. Trust me, that's what low achieving kids do. As soon as they see something they can't do, they throw up their arms and they say, I'm done. Okay. I see it every day. You can't be like that. Okay? Yeah.
In the second one, where you had x, natural log of x plus 1.
Mm-hmm.
What'd you do with the x?
I factored the natural log of x plus 1. Both underlined blue parts in that line, they both have the same factor. That factor is the natural log of x plus 1. So I undistributed it. Okay. The first addend is x natural log of x plus 1. If I factor out a natural log, I just get an x, which is this x. The second addend is just a natural log of x plus 1. If I factor a natural log of x plus 1, I'm left with a 1.
That makes so much sense. So it doesn't matter that x plus 1 is in parentheses and that one is absolute value.
It does, and I'm a little bit worried about it.
So we shouldn't do that.
What?
So we multiply it by
Okay, let's back up here, okay? Back up a little bit. This natural log here, please listen. This natural log of x plus 1 works, this is just one single number. This is not natural log times x plus 1. This is natural log of x plus 1. So this is one thing. If I multiply this, natural log of x plus 1 times x, what do I get?
x natural log of
Okay, that's this one right here. If I multiply this times 1, what do I get?
Natural log.
That's this right here. This minus x is here.
Oh wait, so shouldn't that be x natural log the absolute value of x plus 4?
That is.
No, the one right above that.
Yeah, it would be, but I'm thinking we're just kind of let it go for now.
So
But typically you can't do that.
so technically it is now. Okay.
The idea here is that if we had something about the initial conditions, we'd be able to figure out more closely what's going to happen. Okay? I'm not happy with what happened with this.
Either way is right. If you have it in absolute.
What does right mean?
I don't.
Are they equivalent?
Yeah, equivalent.
We're done. Okay, that brings us to number 10.
Thank you. See you tomorrow.
See you tomorrow. I'm trying to remember what we did here. Okay. We could try U substitution. What's U?
No, it doesn't work.
Why doesn't this work? Okay. Voodoo? What's U?
Oh yeah.
What's DV?
Yeah.
Good. I like that. DU?
Negative sine. Negative ln(x). Oh, the derivative of that.
Times 1 over x.
Yes.
See antiderivative of dx.
Dx.
Good. Let's go ahead and do this. This is going to be equal to x cosine of the natural log of x plus antiderivative of, sine natural log of x
Wait, isn't it x plus?
Yeah, wait.
Negative 1?
What, yeah. What about negative?
dx. What about?
You forgot 1 over x.
No, I didn't.
Because it cancels.
Wait.
With 1 over x and du and v.
Maybe I should slow it down for you. Sorry. Okay, how's that? Is that a good? Is that the good?
Right?
Sorry.
Yeah, you did.
I'm sorry, Mandy just really wants to use substitution. It's gonna be done.
These substitutions are really nice when they work. Okay, let's go ahead and simplify this. X cosine of natural log of x plus the antiderivative of sine natural log of x dx. If you had a crystal ball, do you see what's going to happen here? Ultraviolet voodoo, and we're going to have to add it over. Very good, very good, very good. All right, so U equals sine of log x. dV equals.
Dx.
Good, good thinking. Du equals. Nope. V equals.
Because the integral of cosine and sine is the same.
Oh, you think that? Yeah. I knew that.
Plus x sine of log x minus awesome. This is perfect. This is perfect because now we have antiderivative of cosine of log x dx is equal to x cosine log x plus x sine of log x minus the antiderivative of cosine log x dx. This problem is beautiful. I love this problem. We're going to add the integral to both sides. So now you get 2 times the unknown integral. Is equal to, I'm going to factor out that x. And now I get a constant, right? Divide by 2. And we get 1/2, right? All right, so that means that the antiderivative of cosine log x dx equals x over 2 cosine log x sine of log x. Hey, what's constant divided by 2? By the way, I know I'm getting gripes about this, but the in calculus, really the only base for the logs that counts is log base e. So usually natural log and log are synonymous with each other. Yeah. Log base e and natural log mean the same thing. And rather than saying log base e, you just say log. Okay, here's what we're going to do. We're going to do a couple of these problems. Let's do,
13, 17, 18.
we're going to do 13, 14, 13, okay. We're going to do 13 in class. And we're going to do 14 through, no, we're going to do, we're going to do 14 through, we're going to do 14 through 17 in class, okay? No, we're not doing 13. We're going to start on 14. And we're going to drop dead in about half an hour, okay?
Yeah. We're gonna die.
14.
We're doing 13 tomorrow.
How much space should I leave for the 13?
No. You. You're
13 and whatever else we didn't finish. Okay. Guess what?
What?
This is a U-substitution. What's U?
Cotangent of x over.
I don't know where to have X over 2.
Cotangent of x over 2. du equals
1 over 2, 1/2 1/2 secant. No.
Hey, erase. Cosecant squared x over 2 dx. Let's play the matching game. We have a
Oh, look at that. Hey, that was magical.
we got a cosecant. We got a dx. We got a dx. What we don't have is a negative 1/2.
Makes sense.
So we're going to say cosecant squared x over 2 times dx. That's going to be equal to negative 2 du. So we got that?
Yeah.
Great. That's negative 2
No, yeah, I was right.
times 1/4 u to the 4th. And constant.
Wow, that was very nice.
Which is negative 1/2 cotangent to the 4th of x over 2 plus constant. Why did that turn into a 1/2?
Because it's 2 times 1/4.
Oh, it is 1/2.
Yeah, it's 1/2.
Good.
Why did you put the? Oh no, it's 1/2. Why did I just say that? Is that it?
That's it.
Yes.
Max, not in public.
What?
15.
I know, but we should get Monday off.
Can't do this, Max.
We get Tuesday off.
Focus, please. 15. Antiderivative of x, natural log of x, dx. Can we do a U-substitution?
No.
You can do
We can use... Wait a minute. Integral by parts. What should u be?
X.
Natural log?
Liotte, right?
Oh, yeah.
U should be the natural log.
Okay. Alright, let me go to it. Why can't they just put the U first and not the thing all
Why don't I just do the problem for you?
the time? Yes, please.
That sounds fun.
Literally.
dv equals... It won't simplify.
Why can't you use the tabular?
You would have to be... No, you can't use the tabular method here because your choice of u does not turn into 0. It's a good question. All right, any questions on u and dv?
You have to tutor or you can get
No,
tutored?
I'm getting
Okay, I was like, it's
I wish I get to do it. That would make my life so much easier.
Minus... Voodoo, yeah, thank you. Pizza. Let's see. Are we good? Equals.
It's already dark.
It looks like I could factor out a 1/4 x squared, right?
Oh, you took the infinite and then you multiplied it by the 2. Oh, I get that.
No, dude, it was from Friday. There was some shit. On Friday, every after the party got shut down, people were going in and out, and I was
The sun sets in 4 minutes.
yeah, I didn't go to that one. I went to Caesar's party.
16.
It just started raining at like 11:45. That was the local girls' party.
16 and then 17 and then we're gonna stop. Because I think you guys are toast. I don't know what gave me that idea,
What?
but I think you guys are done.
He's already made us toast, basically.
My brain is fried.
My brain is
Toast and beans.
Okay. Can I simplify? Is this a U substitution?
Yeah, no, but.
What is
yeah.
U?
Tan X.
I don't know how you decide what it is, but I'm
We just did.
Because it's in the radical. du equals secant squared dx. Then you plug it in. Then integral.
Okay, so secant squared x dx changes into a du. And this is nice. This becomes the antiderivative of 1 over square root of u du. I'm sure you know that that's equal to the antiderivative of u to the negative 1/2 du, which is 2 u to the 1/2 plus constant by the general power rule, which is 2 square root of tangent x.
Wait. Don't you turn on the antiderivative?
We did.
Oh yeah.
That
Sorry.
one was,
Wow.
that one was easy.
Now you're too.
Then from the
Thank you. Okay. So hopefully by now you've kind of figured out that although we don't want our answer to have a negative exponent in it, sometimes it's easier if our problem has a negative exponent. We already saw that in at least one place. We're going to see it again here. So the first thing I want to do is rewrite that with a negative exponent for e. Okay. So this is 1 over x squared e to the negative 2 over x dx. So, question. Is it possible for me to simplify this?
no.
Can I use a U substitution? Really? What's the derivative of 2 over x?
2 over x.
Two. Quotient rule.
-2. Quotient.
It is quotient.
It's 2x to the
2x to the negative 2.
Yeah, -2.
Yeah. What are we on?
Good. Did you see that then? You didn't?
It's a U substitution.
Yeah. Negative 2 over x squared. Yeah, negative 2 over x squared.
Jason is saying it as if he like cuts this entire video.
Now do you see it?
That's why it's
Why don't you just? Wait, why do you? Oh yeah.
Oh, you have to.
So I've rewritten it, right?
Yes.
Right, so what's du?
Negative 2
Negative 2 over
x
x
to
squared. Negative 2 over x squared.
Is it 2x or
2x to the negative 2 power dx.
Right.
Oh, okay. Look, I have an x to the negative 2. Look, I have a dx.
So
you just need the
2e
2.
to the negative 2x.
X to the negative 2 dx equals 1/2 du. So I'm trading the yellows for 1/2 du. This becomes e to the u.
Where do we have 1/2? Oh, yeah, we don't.
Hey, what's the antiderivative of e to the u?
Yeah, but
E to the
e to the u.
Sorry, negative exponent.
Right.
No, he's good.
Just really take one
Oh.
to the bottom.
No, that one wasn't on me.
Not a big deal at all.
X plus C.
Just do number 18.
That's not, I don't think
Okay. That's it.
Wait, that's it? That's